Hi, Algebra 1, Period 2, Chapter 1, Lesson 3. So we're doing Lesson 3 now. We're going to talk about different types of numbers. So the types of numbers are natural numbers, and those are 1, 2, 3, 4. Does not include 0. Whereas whole numbers do include 0. So whole numbers would be 0, 1, 2, 3, and 4. We also like to call natural numbers counting numbers, because we have one thing, two things, three things, four things. Whereas whole numbers imply that we can have 0 things, we can have nothing. All right, integers are whole numbers, so 0, 1, 2, 3, 4, and they're opposites. So the opposite of 1 is -1, because 1 is one distance from 0, and -1 is also one distance from 0. But -1 is on the opposite side of 0 from 1. So therefore we say that integers are their whole numbers and their opposites. Okay? Rational numbers are numbers that can be written as fractions. So I can write the number 6 as a fraction by doing 6 over 1. So 6 is a rational number. It's also an integer, and it's also a whole number, and it is also a natural number. All right, irrational numbers are numbers that cannot be expressed as fractions. So like pi. Pi cannot be written as a fraction. So, and anything that does not repeat, and does not terminate is also considered an irrational number. Real numbers are rational numbers and irrational numbers, and there's actually imaginary numbers too, but that's like 3 years from now in math. So let's go ahead and do an example. First example is -12. -12 is a rational number because it can be written as a fraction, -12 over 1, and it is also an integer. The example 5 over 12 is only rational because it can be written as a fraction, but it's not an integer, and it's not a whole number, and it's not a natural number. The example for number 3, -4.67, is rational because this decimal can be expressed as a fraction. If the decimal didn't stop and it didn't repeat, it wouldn't be able to be written as a fraction, and then there would be therefore be a irrational number. But since it can be written as a fraction, it is a rational number. Last example is 6. Already did it. 6 is everything. And then just really quickly, in the gray at the top, those are what we call irrational numbers. Pi, which is 3.14, goes on forever and doesn't stop. The square root of 10, if you do that on a calculator, you'll see it doesn't repeat and it doesn't stop. And then that decimal, it's supposed to go on forever. So just imagine it goes on forever and doesn't repeat. So that's important. All right, next slide. Let's talk about which of these numbers is most reasonable for each situation. And so number 1 is the number of students who will go on a class trip. So this is actually either rational numbers, whole numbers, or integers. They're rational numbers because they can be 1, 2, 3, 4. They can be whole numbers because no one can go on the trip. That would be 0 people. And they can also be integers because integers include rational numbers and whole numbers. And I already gave you the answer for number 2, but number 2 is the height, and it's supposed to be of, not if, of the door frame in your classroom. So that's more than likely an integer or a rational number. I should probably add that in there. Or a rational number, because it could be a fraction. More than likely it is a fraction. All right, using counterexamples, true or false, and then if the statement is false, we provide a reason why it's false. So for number 1, it says all whole numbers are integers. Well, are all whole numbers integers? Remember, whole numbers are 0, 1, 2, 3, 4, and so on. So yes, actually, they are all integers. So true. No counterexample needed because the statement is true. All right, next question. Fractions are whole numbers. No fractions are whole numbers. Well, we have a fraction, and I gave you an example earlier of 6. We can write 6 as a fraction. So it is possible for a fraction to actually also be a whole number. So in this case, I give you the example 2 over 1. 2 over 1 in this case is the counterexample, and you can use a different one if you want. You can use 6 over 1, 7 over 1. Anything that when you simplify it does give you a whole number. All right? So this statement is false because 2 over 1 is a fraction that is also a whole number. So that's why that one's false. All right, next up. We use inequalities to help compare and order rational numbers. All right, so inequalities are like the greater than or less than. But the thing I recommend is that when you are comparing stuff, I recommend putting them into decimals. And when you put things into decimal, you can use your calculator, and the top number goes in the house. So for 1/12, I'm going to divide 1 by 12, and I'm going to get 0.083 with the 3 repeating. That's what the bar over the top of the 3 means, that it's repeating. I'm going to divide -2 by 3 and get -0.6 repeating. The bar over the 6 means it's repeating. And then I'm going to divide -5/8, where the 5 goes first. 5 divided by 8. That's going to give me -0.625. Once I have them as decimals, I can actually compare them a lot easier than as if they were fractions. If I were to compare them as fractions, I'd have to come up with a common denominator. And honestly, I don't want to waste my time doing that, because the common denominator is 24. All of them have to be multiplied. This is just a lot easier, especially since you can use your calculator. All right, so now that they're decimals, I'm going to line them up. -0.6 repeating is the smallest decimal. -0.625 is the next smallest, and the largest is 0.083. Once that happens, I do need to put my answer in, though, using the original format of the problem. So since the format had fractions, I need to use fractions in my answer. So I'm going to go ahead and now replace each decimal with the fractions. And just remember that the inequalities mean that the side that's open on the inequality, and I can actually make this kind of look like a little alligator. Some of my older students who've had me before remember that I like to turn them into little alligators. So there's the alligator. And remember, the alligator is going to go after the biggest lunch. So there you go. Oops. So there we go. All right, next up is absolute value bars. Remember that absolute value bars means grouping symbols. So you have to perform whatever is going on inside of the absolute value bars before you can actually take the absolute value. An absolute value is the distance and something is from 0. So if I'm looking at the number 3, 3 is 3 units from 0. Therefore, the absolute value of 3, which kind of looks like this, is 3. Okay, so the bars, those vertical bars, mean absolute value. And just remember that distance is always positive. I'm never negative feet from something. I'm always some feet from something. So that's what absolute value means. So the absolute value of -4, -4 is 4 units from 0. Therefore, the absolute value of -4 is 4. And then I have the absolute value of -3.7. Well, the absolute value of -3.7 is 3.7. And there is no absolute value of 0 because 0 is 0 units from 0. So that's why the absolute value of 0 is 0. All right, last slide, I promise, and it's an easy one. So inequalities, just to review. We read this as A is less than B. All right, A is less than B. That's what this means. All right, and the next one is A is equal to B because of the equal sign. We have A is greater than B. So remember, the alligator is going to eat the bigger lunch. Let me make that alligator. There we go. The alligator is going to eat the bigger lunch. And so in this first one, B is bigger, so that's the way the alligator is going to face. In the second one, there is no alligator because they are equal. The alligator can't choose, so he's going both ways. And then is greater than, the alligator is eating the A because it is the bigger lunch. So then when we have is less than or equal to, the alligator is going to say that B could be bigger than, but A could also be the exact same amount. Not equal to means there's a like a line through the equal sign, so that means it's not equal to. We don't know anything other than A and B are not the same number. And then is greater than or equal to means that in this case A is greater than, or it could be equal to B. All right, that does it. Sorry it was kind of a long lesson today, but go ahead and start your lesson for today. All right, bye guys.